Hello everyone, good evening, good morning. Welcome to the webinar for high availability in Kubernetes by using replication controller and replica set. So now we can start our today's agenda for the Kubernetes. So today we are going to discuss about the high availability of your application. What is high availability means? Means your ports are always available. Your ports are available, and what is port, and all these things we are going to discuss today. But first of all, welcome all of you on Cognixia platform, so which is one of the world's leading digital talent transformation company. Okay, so we are the world's leading digital talent transformation company. We are the authorized partner of training partner of Red Hat, ITL, and Microsoft, Automation Anywhere, and ISC. So on the screen, you can see that we trained more than 130,000 plus professionals in 45 plus countries, over 4,500 industry veterans as instructors. And we are helping 500 plus companies meet their digital transformation goal. So we provide the centers of excellence in machine learning, microservices, robotics, process automation, IoT, big data, DevOps, cloud computing, cyber security, professional development, and BI technologies. Now let us start today's agenda, which is the high application high availability in Kubernetes using replication controller and replica set. So Kubernetes is an orchestration tool. What is the meaning of orchestration? Orchestration, hi Prabhat. Orchestration is basically the orchestration of the containers. These days, if your applications are running on the container, like Docker is one of the popular container industry wide. So if your application is running on the container like Docker, and that container container application is accessed by your client, so you want your application should be always up and running. Someone will be there who is taking care of that application or that container especially. If it requires the high availability, means it should be automatically scale up, it should be automatically scale down as per the requirement. So this is done with the help of the Kubernetes. So Kubernetes is the orchestration tool which is managing the containers. So when we talk about managing the containers, it means its replication point of view. It should be always up and running. The containers can communicate to each other, and the applications which are running as a microservices. Okay, so microservices are also one of the big topic, but you consider an application is running uh, has its own functionality in its own. For example, if you are saying in the banking application, withdraw service, internet service, so these all are running as the microservice. These all are itself the libraries. And who will manage it? It will Kubernetes who is going to manage this. Okay, so there are different components of the Kubernetes, like we have the pods here, we have the these are basically called resources: ports, config maps, secrets, services, deployment, daemon set, etc. Kubernetes, whenever we are saying Kubernetes, it means it's a cluster. So when we are saying cluster, it means we have master and the worker nodes. Master is the one which is the control plane, and it has its own set of components. For example, they are having the in the masters on the master server, we have the components like scheduler, we are having controller manager, we have etcd database, we have API server. So on the master machine, we install these components. In your course, if you are going to enroll this course, we are going to use the implementation of Kubernetes using kubeadm. We will cover some portion of the minikube as well in this syllabus. We are going to cover the topics which is related to Kubernetes application developer, and the topics which are related to Kubernetes admin. Now let us talk about a pod first. What is pod? Pod is the atomic unit of the Kubernetes. So whenever I say pod, so pod means it is the atomic unit. Atomic unit means it's the basic unit of the Kubernetes. If I say everything, if I say uh, if I say that replication, so replication means on pod. If I say deployment, deployment of pod. If I say daemon set, daemon set on the pod. So ultimately everything will be on the pod. So pod is the basic unit of Kubernetes. Without pod, and what is pod actually? Pod is the pod is the pod is the wrapper of containers. So in a pod you can have single or multiple containers. Daemon set, it's little advanced topic, Rishabh, that we will discuss maybe in the class. So it's little advanced. So daemon set is basically whenever you are running the pod on each and every worker node. So that is the main purpose of the daemon set. Okay, so pods in the Kubernetes are used in two main ways: pods that run a single container and one container per node. In the most of the Kubernetes use cases. So in this case, you can think pod is a wrapper around the single container. Kubernetes manages the pod rather than the managing the containers directly. You are not managing the containers directly, you are managing through the pod. So let me just let us see. We have, yep. Okay. So for example, you have a pod, and this pod is having the container is inside it. Okay, it can have single container or it can have multiple containers. So I have container 1, container 2. So pod is the wrapper of the container. So you are not going to access this. Container is Docker container, Pradeep. Worker node contains the pods and the pods contains the containers. That's correct, Srinath. Okay, so we are having the containers inside the pods. But pod is the basic unit of your Kubernetes. We write Kubernetes K8s also. So this is the basic unit. So if I say replication, so it means replication of the pod. If I say deployment, so deployment of the pod only. If I say daemon set, if I say any object, when we are talking on the high level, ultimately it ends at the pod. If we say services, so services are going to use the pod. Okay, so pod is the basic unit of the application. Now let us talk about the replication controller. So whenever we are talking about the high availability, yes, Rishabh, there is a concept of um HPA, horizontal port auto scaling, and vertical port auto scaling. That option is available. So what is the advantage of the multi containers in the single pod after? So the reason is the reason is that if you have multiple container, you are logically bound multiple container into a single pod. If you want that they can communicate to each other, like your web application and database application, you can put it under a single pod. Okay, so that way we again it's a topic of the discussion because it's a webinar, we cannot discuss in detail, but that is the reason you are combining multiple containers into a single pod. Can you tell the stateful, can we use the stateful application? Yes, we can do it, Paras. Okay, so now let me just first go through this not statefulness, we are going to talk about the replication controller. So what is the replication controller? So for example, there is a pod And on this pod, your web application is running. You have one container inside it, and the web application is running on this pod. This is your client, and your client is going to access this web application. Actually, there is a service layer in between. So we are not going to talk today about the services. But if there is one application which is to be accessed by the client, so that is fine. Okay. So the services are the, you can say it is the outer layer, which is basically going to do a load balancing, and especially it is used for the load balancing of the multiple ports. Now you have one web application, okay, and client is accessing this application. Now there is lot of traffic, lot of clients are accessing, or maybe some background applications, they are services, they are accessing this web application. So now you think that one port with one web application is not enough. So what you are going to do, you are going to create the multiple ports. So I'm creating a replica of this. This is port, same port with the web app. So now what will happen? If multiple requests comes, this service do the load balancing, and these ports are keep creating if there are a lot of requests, and if the number of requests increase, it is scaling up, and if the number of requests decrease, this is scaling down. So it is removing the ports which get created at the end. So this functionality to adding up the resources or to removing the ports is is happened through the replication controller. So you can scale up, scale down your applications, and now this client is accessing this pod, and now there is a requirement that we need multiple ports to be created. So who will create these ports? This will be your replication controller. Your replication controller is the one who is adding up the ports, and your replication controller is the one who is scaling down your ports. So high availability is through the replication controller only. Replication controller is a supervisor for the long running ports. So in short, we call it RC, replication controller. We'll launch the specified number of ports called the replicas and make sure that they keep running. And for example, when a node fails sometimes inside the port, that is in one of the containers goes wrong. So what it means, for example, I have a cluster, and these are my worker nodes, worker node 1, worker node 2, worker node 3. And there is a concept of the desired state, and there is a concept which we call the current state. So you are saying I need 3 replications of my pod. So this is the requirement, so desired state. And how many of them are running? That is the current state. So say an example, 2 are running. So replication control comes into the picture, and it is something which is infinite loop, which is keep checking that current state is equal to desired state or not. If it is not, then replication controller add one more port over here, and it means now 3 out of 3 is running. Now how replication controller knows that this is this particular port belongs to a particular replication controller? That is on the basis of labels. How replication controller is going to find the ports which belongs to this replication controller? That is on the basis of labels. Labels plays very important role in the Kubernetes. Whenever you are creating a replication controller, so the replication controller has a port template. Okay, replication controller has a port template, and this, on the basis of this port template, the new ports get created. So for example, tomorrow you are saying that I need to create a port with uh, I need to create a port with some specification. So that port will be that particular port will be created on the basis of this template. So port template is a template which is a part of your replication controller definition. So whenever you are creating a replication controller, it checks the port definition and it creates that pod. So this is the replication controller. Replication controllers are equality based. So what is equality based? Means equal to symbol. So for example, I am using a selector by saying that I want to find the uh, I want to find the pods or replication the ports which are in the replication controller where environment equals to production. So it will show all the ports which has label environment equals to production. But if you want to if you want that it should be some operators, like we want to use the operator in, not in, or exists, then we use a concept which is replica set. So replica set is same as replication controller, but it is set based. So this is equality based replication controller, and replica set is set based because we are going to use these operators to create the expressions in the replication set, replica set. So that's why we call replica set as next generation of replication controller. Let me move to the next slide. So now let us discuss about the replication controller or replica set. Both actually work in the same way, but as I mentioned, the difference is that replica set is the next generation of the replication controller. So if there are too many ports, the replication controller terminates the extra ports. If there are too few ports, replication controller starts more ports. Unlike manual created ports, the ports maintained by the replication controllers are automatically replaced. If they fail, they are deleted or terminated. For example, your ports are recreated on the node after disruptive maintenance, such as kernel upgrade. For this reason, you should use the replication controller even if the application requires only single port. So you have maintained a replication controller state of a pod by saying that I need only three three ports, and three ports are running on three worker nodes. Worker nodes are nothing but your virtual machines. And when one of the virtual machine is down, so current state is not equal to desired state. That machine is down because you want to upgrade the operating system, kernel upgrade, or maybe that system is decommissioned. So now it is the responsibility of the replication controller to maintain the current state equals to the desired state. If current state equals to the desired state, it means replication controller is, if you have defined, it is working behind the scene, and it is creating and it is supervising that the number of ports which is in the current state are equal to desired state or not. If new ports is required to create, then it creates the new ports. If the old if there are some extra ports which is to be reduced, then again it is happening with the replication controller only. So load balancer work is, Srinath, it is done by the services, but yes, it is used for the load balancing purpose as well. Yes, Dipali, replication controller has the port template as a definition. Yeah. So these are two terms, pod and port. Port is different. Port is your port number. So it depends. By default, it is replica of one Mohit. Okay. So how the communication between the ports is possible? So that is possible with the help of the port network. So we define a port network. We are going to use a plugin which is Calico to define the pod network where the pods can communicate to each other. In case of the multiple load balance pods, how you address cross-cutting concerns like logging, error handling. So yeah, Aftab, that is monitoring and logging portion will cover in the course how to configure, how to manage that. We use multiple concepts like for debugging point of view, we use the describe. We are having a concept of volume where we can store the multiple logs. All right. So now let me show you practically. Replication controller can manage running multiple cluster. So replication controller is mostly we use for the single cluster. Kubernetes is a part of DevOps technology. Yes, that's correct. So I think Neeraj, you joined late, so you can go through this recording. In the beginning, I have explained. You cannot see away others' chats. Yes. All right. So let me just. So I have a cluster. If I say kubectl get nodes, so you can see that I have three node cluster. So I have one master and two worker nodes. Okay, and all are in the ready state. So if you want to see kubectl uh, get all, so I don't have any pod defined here. I don't have any replication controller replica set. So if you want to create a pod, let's create a pod quickly. So if I create pod.yaml file, okay, so I have one YAML file. Let me remove this. If I say rm star and ls vi pod.yaml file, I'm creating one YAML file. And here I'm just defining API version v1 and kind is pod and metadata, and I'm defining the metadata name of the pod is pod1, and I'm defining the labels. So label I'm defining app is Nginx app. Okay, and now I'm defining the specification. Okay, if you are not understanding this YAML code, no need to worry. You will be get familiar once because I'm taking a part which is in between of the course. It's not from the starting. So this webinar is more for the replication controller and replica set. So probably you may not understand this code because this is totally new to you. If you are new to Kubernetes, you may not understand this YAML, but you will be understand soon. Means uh, in the beginning lectures of this Kubernetes. So I'm going to define the containers inside it, but I will try to explain you here containers, and I'm defining a container, and name of the container is you can give any name c1, and it has image as Nginx. So what I'm going to do here, I'm going to define a pod. So Venkatesh, Ubuntu is an operating system. I'm creating YAML on master Shriram. Yes. Multiple Kubernetes nodes can run on the Docker images. Yes, Anshul, you are correct. Okay, so now, so this is basically the way we write the pod. It starts with the API version and then kind is pod. Whatever you want to create, if you want to create replication controller, you can say kind as a replication controller. And then name, I'm defining the name pod1, and Labels, I'm defining the labels app equals to Nginx app. Labels are mostly used for the selection basis. For example, you are running 100 ports and you want to search a particular set of ports. So you can search on the basis of the labels. Okay, and inside this pod, I have container which is C1 and it is Nginx. So if I save this and if I want to create kubectl create -f pod.yaml file. So I'm creating this pod. Okay, sorry guys, there was a disconnection. Okay, let me connect again, sudo su. Now I have created that pod. If you want to see how many pods get created, kubectl get pods. So now you can see there is pod 1 get created. Now you want to see where it get created, -o wide. So it is running on worker node 1. So I have uh, three node cluster. So one of them is worker node 1, worker node 2. So it get created on worker node 1. You can put a condition that it should be running on the specific node. So we use the labels on the node level in that case. Okay, Ganesh, I will explain that how the replication controller comes to know. So here, kubectl get ports -o wide. So you can see I'm able to create this pod and this pod is in the running state. 1 out of 1 means one container inside this pod and it is in the running state or it is in the ready state. Okay. So now let us, if you want to see what is inside the pod, you can run a command kubectl describe and the pod name. So you can see these are the events which occurred, how the pod get created. It will be first assigned to worker node 1, pull the image of Nginx, and then created the container C1 and started the container C1. Okay, and other description like we have defined the label, we have defined the image, there is a container ID. So all that information you can get it from the kubectl and the okay. So Gary has a question. Do you have to create the replication controller and is automatically done? No, we need to create it, Gary. Okay. So now, so this pod get created, but if I delete this pod, let me delete this pod. Kubectl delete, uh, delete spelling is correct. Delete pod and pod 1. Okay, so when I'm deleting this pod get deleted, but there is no one who is taking care of that. Means whether this pod 1 is deleted, whether it is running, it is only on Kubernetes level. But I need someone who will take care this pod is running or not. If it is not running, restart it, recreate it. So that is the job of the replication controller. So now you can see pod get deleted, and if I say kubectl get pods, so there is no pod running and no one is there who can take care of this. For that purpose, we are going to use the replication controller. So let me create a replication controller.yaml file. Okay. So basically now what I'm going to do, I'm going to create a code. I'm going to write a code which is related to the replication controller. And that replication controller will create the pod on the basis of a template. So, so this is the code I am writing. API version v1, kind is replication controller. So In the previous example, kind was pod because I was creating pod, but here I'm going to create the replication controller. So I'm saying replication controller is the kind. Metadata. Metadata is the data about data, data about your replication controller. So the replication controller is having a name nginx minus rc. Now the specification. How many replicas you want to create? So that is your desired state. So I want to create 3 replicas. So replica is 3. Template. So this template is your port template. Okay. So this template is your port template. So here I'm defining the template. Metadata name equals to nginx pod. So this is the name of my pod. Labels. So again, as I mentioned, how replication controller identifies that these ports belongs to me or not. This will be identified by the labels only. So down here you can see the selector also. So selector should be same as your labels. Specification of your pod template will be the nginx container inside it. So if say an example, I'm creating 3 replicas. So all these 3 replicas will have the same properties as we are defining under the template. Okay, fine enough up till here. Let me see anyone has any question. Replicas means how many containers how many ports you can say, Rishabh here. Is the replica set is the modern type? No, yes, replica set is the modern type. That's correct. What are the use cases with label and selector different? No, there is no use cases. It should be same. So selector to select your ports. Container port 80 means my container who is running that application on the pod is running on port number. Nginx runs on port 80. Are you going to provide the details about the imperative commands also instead of declaring in YAML? Not today's session, yes, but in the class it will be there. Can we change the container port? We can change, but you need to run the applications over there. But the port is not secure. Yes, in this example, not secure, but in your actual application, it will be 443 port with some certification with your image security. All right. So, okay. So, can we set the default port? Yes, you can define the port number here in the container port. What is Nginx? Nginx is a service basically, which is a web server. You can think it like this. Okay. So now let me just create this this replication controller quickly. So what I will do, I will save this. Replica 3, yes, 3 replicas, yes. Yes, we will select on the basis of this. Yes, on the basis of the labels. No, it should be the same template, same port Vimal because it is on the basis of the template. So now this particular replication controller.yaml file get created. Now what I want to do, I want to create this kubectl. First, let me see, is there any pod running? So there is no pod running. If I say kubectl and create -f replication controller.yaml file, so it will create the replication controller. Now if I say kubectl and get pods -o wide, so now you can see there are 3 pods are running, and all these 3 pods are spread across on my worker nodes. 2 are running on worker node 1 and 1 is running on worker node 2. Okay, so these are the machines, virtual machines in my cluster where these ports are running. Okay, when this get created, 11 seconds ago, 1 out of 1 is ready. So now there are 3 ports which are running. Now I want to remove one of the port. See, when I'm going to remove one of the port, so current state is not equals to the desired state. So you can search that kubectl get replication controller. So in the replication controller, desired state is 3, current state is 3, and 3 are in the ready state. And also you have noticed here, the name of the replication controller is this, and all these ports get created with this hyphen and then some random value. Now what I will do here, I will delete one of the pod. So let me delete kubectl, delete pod, and let me delete first one, okay, which is qk in the end. So I'm deleting this pod. Once this pod get deleted, now let me just see kubectl get pods. See, new pod get created. Which one is the new one? This one is not this one. GM. See, 7 seconds ago it got created. So when I removed a pod, so replication controller reconciliation starts and it checks that current state is not equal to the desired state and it is going to create a new pod. So now my replication controller determines that, again if I see get replication controller, and you can see that 3 out of 3 is running. Now you want to see what replication controller has done. You can check it out with the kubectl describe and the replication controller and your replication controller name. So here you can see that first it has created these 3 pods, but because we have deleted one of them, that is why it is searching. The current state is not equals to desired state, so it has created one more pod. So one more pod get created with the help of the replication controller. Okay, so can you give us the hierarchy example? Who talked to the Kubernetes replication controller? Since we create 3 ports with the replication controller, it is self-maintained once it is created. Why would you create a pod without using replication controller? Okay, so the one which I have created earlier, that was just to show you that how to create a pod so that you can understand what is the template structure, because in the template we are going to create the pod. How much memory allocated to the pod, that depends. So whatever the memory you are assigning to the pod, this is scaling up, which is in the AWS according to the traffic we get. Okay, scaling up, scaling down. So far we are just running the pods with the replication default state. If you want to scale up or scale down, that is also possible. So how can you see the memory of the pod is using? You can use the kubectl describe pod name command. All right, so now let me show you how you can scale up or scale down for your application. So what I'm going to do here, I'm going to run a command and okay, yeah. So I'm going to give it run a command kubectl scale replication controller, name of your replication controller hyphen hyphen replicas equals to 5. So current state is currently it is running with the 3 desired state. So I'm changing the desired state to 5. So I'm saying that there should be 5 replicas running, and if I press enter, now my replication controller is scaled up. So if I see kubectl get replication controller, and you can see now the desired state is 5 and current state is also 5. Now you want to confirm on the pod level, kubectl get pods minus o wide. So now you can see 5 ports are running. in your cluster. Some of them are running on worker node 1, some of them are running on worker node 2. I have 3 node cluster. On master it does not run because master node is tainted. Okay, what is taint, that is a other topic. So you can consider at this moment the pods are not getting scheduled on the master node. So this is in the running state and 5 out of 5 is running. Again, if you want to try that to delete one of them, so it will maintain the current state equals to the desired state. Now here you can see these 2 ports. These are newly created ports. So if I scale down my application, so it will remove these ports. Okay, so if I say kubectl and scale down to 3, so these 2 ports DJ, ZX or ZJ, so these ports should be removed. Now if I say again kubectl get ports, and here you can see the ports which was created at the end are getting deleted first. So by default, these are deleted in this fashion, last in, first out. Now, if I run my kubectl and describe and replica set nginx replica replication controller. So here you will find entire history what the replication controller has done, whether it has created something, whether it has deleted something. Every recording will be here in your describe command. That will be very useful when you are debugging or you are troubleshooting your replication controller. There will be other properties also you can see over here, like your labels, selectors, your port template. Everything will be described under the replication controller describe command. If you want to delete the replication controller will be deleted. The ports which get created along with the replication controller will also get deleted. So for example, if I say kubectl delete -f replication controller and .yaml file, so my replication controller get deleted. Now if I say kubectl get ports, so you can see there is no port running because I have deleted the replication controller. If you say kubectl get replication controller, so there is no replication controller. So this is how the replication controller works. What is replica set? Replica set purpose is same as replication controller. Replica set is called the next generation replication controller. The main purpose of replica set is to create the ports into the desired state. So similar way as we are doing in the replication, exactly same. The difference is that replica set is set based, whereas replication controller is equality based. So what is set based and what is equality based? So when you are using a selection, uh, into your replication controller definition, you are using equal to symbol. So say an example, this is the example of the selector. So what I am writing here, selector, and I'm saying app equals to, so it is equal to, it means selection is app equals to nginx app. So if you want to search your ports, if you want to search your uh, replication controller, you can use the equal to. That is why it is called equality based. This is set based. Okay, so what is set based? You are going to use in, not in, exist, these operators. For example, if you are searching your ports where environment equals to production, but here you can see environment in production, or you can give the multiple values. So say an example, if I say kubectl get ports where environment in production comma quality assurance. So this will give you the list of the ports which has label environment either production or quality assurance. In the selector point of view, you can use the match label, which is same as your manifest selector in the replication controller, means equality based, and you can use the match expressions as well, like key is the tier, operator you are using in, and values you are using front end. So it means this will help you to write the query on the selection based. You can use, like here we are using this because we are using this kind of match expressions. All right. So this is how the replica set and replication controller works, and they can communicate to each other. They can communicate to each other means, sorry, I just need to take my words back here. So they are how you are comparing replica set and replication controller. So this is what I want to show you here. Okay. All right, guys. So I need to end up this session now. So you can use the support at cognitia.com. Thank you, everyone. It's really nice to have this session. Thank you very much.